So I got another hour or so to make this video. So before I cannot make it, I think. So I'm gonna do it. So welcome to week 11 of regaining my grade in geography. You know, I don't want to get 60%. And today we're going to be discussing hazard events and their prediction. So this video is going to kind of be split into two, and I'll explain later why. So the full question statement is: examine the methods used to make estimates, predictions of the probability in time and space of hazard events occurring and of their potential impact on the lives and probability. No, their lives and property. I can even read my own handwriting. Well done. Discuss these case studies relating to two different hazard types. So we're going to just be looking at earthquakes today because it's pretty chunky. And next episode we're going to be looking at volcanoes, I think. I mean, you could call like earthquake and tsunamis kind of the same thing because tsunamis mostly occur from earthquakes. So there's a 2-in-1, Miss Sarah. You know, this is used for two different types of hazard events. So checkmate. So we're gonna discuss the seismometer, which senses the vertical motion, so only the vertical motions of a continental plate, which the more a continental plate moves, the more likely chance that an earthquake is going to occur, like a larger scale earthquake. You know, so a larger scale earthquake occurs right after the smaller tremors, which the seismometer records, and it produces recording. So the recording it produces, the paper, which has a recording, is called a seismogram. Seismogram. There you go. So basically it works. I'll try to demonstrate it here. So there's a piece of paper in the frame. There you go. There's a piece of paper, and which moves. It's a constant moving piece of paper, and there's a weighted pen, right, just with the tip touching the paper. Now this weighted pen does not move. It resists the shaking of the earthquake. Well, the paper itself does not. So usually it goes like this, paper is flowing through. But when there's an earthquake, the paper moves, but the pen doesn't. So when the paper moves, the pen actually is able to mark, and the more vigorous and the larger the pen marks on the paper, on the seismogram, the larger the tremors, which is a stronger indication of earthquake. Because technically it is an earthquake, but it's so small, it doesn't really matter. Most seismometers are underwater, since 90% of all earthquakes occur underwater. So this is largely because of earthquakes. I mean, earthquakes occur when there's the borders of continental plate kind of rub against each other. And sometimes they get so friction and pop like that, and big burst of energy tremors the earth, or even like just that's tsunamis. Never mind. But tsunamis are also caused by earthquakes, and usually a tsunami occurs when even it's just a tiny bit, just like that. Like these are two crusts, two different continental plates. If they just slightly move, all the water rigorously shakes and a giant wave is formed. And seismometers can even detect tsunamis, since a lot of tsunamis occur, or I'm pretty sure all tsunamis occur due to most modern tsunamis, I guess, occur when two continental plates collide or has a problem, and it's have a lot of movement, which is the same thing as an earthquake. So seismometer can theoretically, and it probably does, because when there's an earthquake, there's a tsunami, as we've seen in Japan in 2011, that there was a giant earthquake off the coast of Japan, which was then followed up by a tsunami because of the earthquake, because of the continental movement stirred up the water, causing a tsunami. And since tsunamis and earthquakes are caused by the same thing, and seismometers are able to record an earthquake. Not record, predict. No, not predict. Measure. No, not measure. Foresee an earthquake, and an earthquake is the cause of tsunami. Seismometers kind of do both. So yeah, and many places that use the place that uses seismometers can be, Canada and California. So usually places that have a large amount of earthquakes. And so California is one of the most impacted states, or the most impacted state of America when it comes to earthquakes. So much so that there's like a continental plate border right there in California, hence a lot of earthquakes. Fun fact, I don't know if this counts, but it's Friday. Here's a fun fact. Japan, researchers in Japan actually noticed that the more active, found a positive correlation between the movement and the activity of catfish and an earthquake. Hence, so usually the more active a catfish is, the more it's swimming around its tank. Usually, the more chance it's going to be an earthquake. As in, the catfish really detects the earthquake. It's just that it starts to move, and it's kind of a prediction of an earthquake, because usually catfish, they're just there, bottom of the tank, not doing anything. But right before an earthquake, they start to move around a lot. So hence, there's a positive correlation between earthquake going on and the increased movement of catfish. So there you have it. Another, not sure how reliable that source of prediction is, but there it is. Hope we have an awesome weekend, and hope I get a good grade in geography.